I'm pleased to be here. I think you'll enjoy our time together. This particular topic is very high on the radar, very visible on the radar nationally. I just came from an Engineering Deans Institute conference earlier this week where all of the engineering deans in the country get together, and full 25% of our conference was devoted to what do we do about alternate energy sources, energy in general. It's with pleasure that I announce that with significant help, as in he's done everything and should be applauded for that, Dr. Ghavi. From Dr. Ghavi, we have with us today Mr. Michael Mylrea.
Close enough.
I better put my glasses on. From the U.S. Department of Energy, Mr. Bernard Lecours from GE Energy Management, Ms. Patty Durand from the Smart Grid Consumer Collaborative, and Mr. Alan King from Yingli Green Energy Americas. And rather than give you their bios, I've asked them to give us a couple of quick sentences on how they got to the position that they're in, what brought them to the position they're in today. With that, I'm going to turn it over to Dr. Ghavi, who will frame our discussion.
Thank you very much. Thank you much, Dr. Currin, and thank you all. Thank you, Dr. Gal, for arranging this meeting. And thank you to our panelists who have come from far to be here with us this afternoon and answer some questions regarding smart grid and green energy. Not long ago, if you would ask someone in the know about what's smart grid, they would say that this is a smart system that provides exchange of information between suppliers and consumers, and that was just that. Nowadays, that definition has expanded quite a bit, and it's getting into a number of different areas that I'm hoping we will have a chance to discuss this afternoon. To sort of frame the discussion, we are hoping that this afternoon we would have an idea to get a good fix on where we are with respect to green energy and smart grids. And because the technology is a dynamic and evolving technology, the next adjacent question to that one would be, where are we going? And what's our sense of direction? And then the third factor that's just as important has to do with the opportunities and challenges. There are many challenges, but where there are challenges, there are also opportunities. What are the opportunities and challenges in terms of technological opportunities and challenges, as well as business opportunities, with the focus on the Asia and the U.S. regions. We also asked our panel members to prepare a 6 to 8 minute presentation, and they will do that first to sort of give us an idea as to what is on their mind in terms of the concept of smart grid. And once they're done, I'm hoping that we will have lots of questions from the audience. After all, this is supposed to be a sort of a roundtable discussion, not amongst ourselves here, but also between us and the audience. So without further ado, I'm going to ask Mr. Bernard Lecours to step up from GE and do his presentation. Thank you.
Great. Thank you very much, Dr. Ghavi. Just a quick note on my background. I've started my career in Canada working for utilities, and then crossed over to the dark side working for the vendors. And I've been with GE for almost 15 years. So the first thing I want to do is talk quickly about statistics. So why do we care about green energy, and what's smart grid in the mix? So just some basic statistics. the installed capacity in Asia of generation capacity is growing at about 5% year over year, whereas renewables is growing at about 13% in the next decade. So almost triple, the ratio. In fact, in absolute megawatts, we're going to quadruple renewables in the next 10 years. The renewables at the moment have about 10%, penetration, across the entire portfolio. It'll grow to about 17% by 2020, and then we're going to be close to a quarter of the installed capacity by 2025 being renewables. 94% of that's going to be solar and wind. So imagine, the amount of intermittent resources that are going to be placed on the grid. In the meantime, we've got a population that is evolving, and a lifestyle is improving. So we'll see 40% increase in per capita consumption during that same time frame. So we are going to see energy transformation, not only from the energy provider side, but also from the consumer. So I have a story to explain what the challenge is going to be in front of us, and I'm going to use the example of SDG&E because they've experienced a lot in the last few years. SDG&E is at 25% renewables today. So what we are going to see in Asia is already happening in California and several other states, and also overseas. 25% renewables, about 2% of their customers have solar panels, and it's growing at a rate of 3 to 4% every other year. They're telling us that about 20 of their circuits are at 20% plus penetration of solar. And everybody agrees in the industry, if you reach 20%, you're starting to have a lot of problems. So you've got a lot of voltage variation on the circuit. And how does this happen? Just picture you're a customer on that circuit. It's a June gloom because they experience June gloom in June, where there's cloud cover and everybody's drawing power from the utility. And then by 10 o'clock, the sun, the clouds dissipate, and all of a sudden everybody starts generating. So the impact on the grid, particularly on that circuit, and certainly the rest of the grid upstream, is grand. We're seeing voltage variation, as I mentioned earlier, and then also VAR variation. So typically, on a normal circuit, you would have sort of electromechanical devices that would, kind of compensate for the variation in the substation. And the voltage, typically would vary such that these devices would operate maybe 4 or 5 times a day. But with the voltage fluctuation of solar, we're looking at 90 to 100 times a day. So you can just imagine the impact on the asset lifespan. So not only will we have issues around the volatility of the system and the reliability, but also the fact that now some consumers will start backfeeding into the grid. So we're going to go into a system that was designed and protected for a one-way flow of electricity from generation down to the consumer, and now we're going to start seeing the opposite flow. Not designed for this. The protection infrastructure was not designed for that, and potentially there might be some utility workers working on those lines, not intentionally, but could be in a safety situation. So what's smart grid? In a nutshell, smart grid technology is really the internet for utilities. Just visualize that, it's the internet for utilities. There's some basic elements. We have smart sensors that are sitting on top of the electrical infrastructure to monitor, to protect, and control the infrastructure these devices, these smart devices, have embedded communication, so they can communicate with one another, but also communicate all the way up to the utility enterprise into software applications that utility operators, engineering, and maintenance folks use to, to operate the grid. Two of the very important elements in a smart grid is really communication, and the other one is IT. Communication, because we need to understand how much communication is needed, what's the bandwidth, what's the frequency, and as you expand the smart grid infrastructure with thousands and thousands of smart devices, you're going to have to really consider, model what that communication infrastructure, will be and is needed. So it is a very important step in developing a smart grid. The other part is IT. Again, consider all these thousands and thousands of devices that are going to generate data. So when everybody talks about big data, well, it's really happening. So to manage the data transfer, analyze the data, having these smart devices interface with the central office is going to have a big impact. So just a quick example of what smart grid is going to do is envision a utility already knowing when you call that there is an outage. They already know where it is. They already anticipate what sort of crews they'll need to get there before you even started calling. So we're talking seconds versus minutes, hours, which it would take us otherwise without having all this smart on the grid. Think of, in fact, renewables. The smart grid technology will really enable us to better forecast what's coming, to better operate and interface, all the renewable, generation on the grid. I can talk about a lot of these topics, but, there's at least a dozen very good applications where we are going to see tremendous transformation. Just before I go, I need to stop. She says I need to stop. But before I go, there's certainly challenges. I described some of the challenges, but there are opportunities. We're seeing power electronics emerging in the marketplace, power electronics being part of that smart grid technology family of products. And what power electronics is going to do is going to emulate what our more traditional electromechanical devices have been doing in the past, like capacitor bank and tap changers and voltage regulators, all these devices that have been on the grid for a long time to help us with reliability, but power electronics can operate extremely fast. So it's a good mix with the intermittency of solar and wind. So I'm just going to stay there.
Our next presenter is Mr. Michael Mylrea from the U.S. Department of Energy.
I met May, I think, about 2 years ago. I was giving a speech on the future of energy at the White House, and I was really hoping today that I could, take that speech off the shelf, change some dates, put some new visuals in there, and give the same speech today. But a lot has changed. Let's see, do we have the presentation? Are we able to pull that up? Okay. I don't know how much a cybersecurity doctoral fellow is worth that can't use a PowerPoint, right? So I realized about 2 weeks ago that I had completely changed my presentation. I really had a rude awakening. Literally, I woke up, it was about 120 degrees in my house. I was sweating, but it was cool outside. So I really did not know what happened. And then I remembered that I had left my iPad with my 2.5-year-old daughter. And she had opened up a smart app which controls my smart thermostat and cranked up the heat, which in turn sent a signal back to the utility, which collects, aggregates, and makes decisions based on that data. So that was my rude awakening that the presentation I gave 2 years ago was not relevant anymore, that the future of energy is already here. The last 100 years, the basic business model that kind of governed the power sector was one-way communication. Utility would generate, transmit, and distribute energy, and you'd get a bill at the end of the month. There was really no two-way communications or interaction between the consumer and the utility, and that has really all changed. I saw another example on the way to the conference, what I call...
And if we look at the slide I have up here, you can see that from 2004 to 2014, we've seen prices drop from $8 a watt down to $4, driven primarily by access to large volumes of solar modules manufactured in China. Because of economies of scale, because of a more established supply chain. You wouldn't think that, but because of a more established supply chain and less expensive labor, cost of a watt of solar has dropped from, we'll go back to 2004, about $4.50 a watt to close to 60 cents a watt. So we've seen significant growth, and that's led to any number of things, adoption both commercially and residentially, and a huge growth in the solar industry in the United States. And with that, and with that came trade cases. Arguments that the Chinese manufacturing, Asian manufacturing was putting American manufacturing, we're closing down American manufacturing facilities. The truth behind that is that the advent of less expensive panels from China did more to increase employment than it did to harm employment. Right now, the United States, the solar industry employs about 200,000 people. It is one of the fastest growing segments of the U.S. economy, and it shows no signs of slowing down. As a matter of fact, we expect to see significant growth in the industry this year. And again, it's led by a symbiotic relationship between Asia-Pacific production, U.S. energy demands, and the ability for U.S. companies to install product in the United States. So if we move on, we can talk about cross-Pacific partnerships really impacting the energy picture in the United States, really helping us grow our market, really helping the United States to become more energy independent. And if we look at it, as was said earlier, the fastest growing segment of the energy economy is solar industry. It's growing at a rate well in excess it's actually the second fastest growing behind natural gas in the United States. It is a huge opportunity, one that's been fueled by a very symbiotic relationship between both China and the United States. And I have about 10 more minutes, but I've been told to stop. So I want to thank everybody for their time. And if you have any questions, you can come up and talk to me afterwards, or we can do this again. Thanks very much.
Thank you, Mr. King. In the equation of smart grid, on one side, of course, we are producing. On the other side, we are consuming. And therefore, the reaction of the consumers and the way they look at smart grid and their rate of acceptance, et cetera, is a major factor. And in order to address that important element, we have asked Ms. Patty Durand with Smart Grid Consumer Collaboratives to give us her point of view and her take on consumer reactions with respect to smart grid technology. Ms. Durand.
Thank you. So what I want to share with you today are 4 broad concepts regarding consumers and the smart grid. One is, who is out there, what do they think, and what do they want? The second one is, what do consumers know about smart grid or grid modernization? The third is, what is segmentation and why does it matter? And the fourth is, what do consumers say they want regarding green energy? And I realize this is a conference focusing on Asia. Asia is going to be the biggest driver of smart grid investments over the next decade. And a lot of those investments have to involve consumer understanding and awareness and interest in the programs and services that grid modernization will bring, including rooftop solar, including demand response, including energy efficiency. So the fact that the U.S. is a little bit ahead of Asia is a good learning opportunity for Asia to come now, being the next biggest driver after the U.S. and North America and Europe have already made a lot of these investments that are now happening in Asia. So, good, got my slides up. Okay, so first off, who's out there and what do they want? Who's out there in terms of energy awareness, energy interest? What are consumers' attitudes about energy? What are their values? What do they think? What do they want? We weren't able to answer any of those questions. A lot of those questions were answered anyway by conjecture, by hypothesis, by guessing, and many of them were answered by industry insiders who honestly didn't know and had never engaged with consumers, not out of malice or misbehavior, but because they've just never had to, because there was no opportunity to. We're just now at the stage that high-speed computing, big data, digital devices like the smart meters and sensors that Bernard mentioned are happening. But previous to this last decade, they were not happening except in rare cases for only the largest commercial and industrial customers, but certainly not happening at the residential level. Now they are, now they're here, now they're installed, and they're going to be installed worldwide across Asia, across Australia. England is beginning their rollout and so forth. So this dynamic has changed, and utilities need to understand who their customers are, hence the question, who's out there. They need to understand what their customers want and how to reach them, how to communicate with them, how to create programs and services and market to them around things that consumers care about. So we've spent the last 5 years doing a lot of research around the U.S. residential consumer market, and I want to share a few things with you so that you can see what that might look like in Asia. Or have you ever heard of the term smart meter? And by vast numbers, consumers have not heard of either term. And in the U.S., that usually comes as a shock at conferences that I speak at, because we have marinated in these terms for 10 years. They seem ubiquitous to us, and the fact is that consumers haven't heard of them is astounding. But they haven't, and they still haven't. We've tracked this from 2011 to now, and those numbers have not changed, which is what these bar charts will show you. Yeah, that's not worth spending the time describing, but I'm pretty sure you'll get a copy of the slides and you'll be able to read them really closely yourselves. So we have the data, and the data says consumers aren't aware of these terms. 50% have never heard of the terms, 20 to 22% have heard of the terms but say they don't know what they mean, and now we're in the 70s who have either never heard of the terms or have heard of them but don't know what it means. And only 25% of U.S. consumers say they know what it means and have a fairly complete understanding of it. In terms of segmentation, we've created a segmentation framework made up of 5 broad segments, which you can see on this table. Those 5 segments divide people according to their attitudes and values around energy. So, of course, some people don't care about energy much. They want to pay a cheap bill, and they want the lights to come on when they flip the switch, and otherwise they don't care. But our research shows they're a minority. The majority of people do care, and they care for different reasons, which we've segmented here in this table. But the problem, at least in the U.S., is that a lot of industry insiders or long-term industry leaders think that the people that don't care are the whole pie, make up the whole group. And that's just not the case. That's not what our research shows, and as far as I know, there's no research that shows that to be true. So for example, Green Champions is the largest segment. They make up 30% of the U.S. population. This will vary from region to region. Certainly in the southeast of the U.S. it would be smaller. In the northwest and in California and the northeast it would be larger. In Asia the numbers would likely change a bit as well. But what this means is that these people care about energy as it relates to green energy or clean energy. They care about climate change. They'd like to buy rooftop solar. They don't want to waste energy. They think that global warming is an issue and they want it addressed. The next segment is saving seekers, people that want to save money on their bill. The next segment is status quo. This is the group that says, we don't care, don't bother us, we're fine. And then technology cautious. This is a group that does want to save money and thinks technology could be helpful, but they don't know how and they need to be educated. And the last one is movers and shakers. These are the people that care a lot, they like technology, they go online, and they would engage around energy in any number of ways. That's who we've identified as who's out there. And then what about green energy? What are consumers' attitudes and concerns about that? What we've done is tested consumers' opinions on grid modernization across 3 broad benefits. And what I want to share with you today, what I want your takeaway to be, is that the number one benefit that consumers have told us, all consumers, not just the green ones, that they care about grid modernization because it'll bring about a cleaner portfolio mix from their utility. That really surprised us. We didn't realize consumers cared that much, but our data shows they do. And that's the middle one where you see the 86% for total importance. Other benefits, of course, include reliability. As Bernard explained, utilities now know when an outage happens, where it's happened and why, and can send the truck roll much quicker. In some cases, you can avoid an outage altogether because they can automatically reroute power around an outage. And then economic is another huge benefit. Consumers like being able to control their bill and budget, of course. And then another important concept to share with you is that consumers are interested in being able to be more empowered. They like to enroll in pricing plans. They like to know what their bill is going to be. They like to purchase green energy if they want to. They like to automate things if they want to. Consumers like the whole idea of they're in charge. We also have a consumer value proposition project that we're working on, and by this I mean that the Smart Grid Consumer Collaborative, my organization, is working to understand how to explain all this to consumers, because we're certainly not going to talk about truck rolls, we're not going to talk about demand response or volt var or any of that engineering stuff. We're going to talk about things that consumers care about in language that they know and about the things that the consumer cares about. So we've done a lot of research on this project. We are working with Edelman, a global PR firm, to determine how to talk about these concepts to consumers. And I'll be glad to answer any questions about that or send you our work if you give me your business card afterwards. And I look forward to Q&A with you. Thank you.